Morning, everyone. Our first session, I'm delighted to say, is with Chris Anderson, who I'm sure you're all familiar with, a former tech editor at The Economist, then the editor of Wired for many years, now running his own company and most recently, author of many books, most recently, Makers, the New Industrial Revolution. So here to talk with us about new industrial revolutions, please welcome Chris Anderson.
Thanks, Chris. Thanks, Tom.
OK, well, let's get right into it. A new industrial revolution, that's a big claim. So what do you mean by a new industrial revolution?
So industrial revolution is a big word. And I'm going to argue that broadly there have been three. The first was the mechanical one. That was 1776, spinning jenny, water frame, and all that. And that was the replacement of muscle power with machine power. So this sort of elevated human potential from beast of burden to beast of brain. And productivity exploded, lifespan was doubled, population, et cetera. That took us to the mid-20th century, or actually I would say the late 20th century, and the second industrial revolution was the digital one, the information age, which was not the invention of the computer, but the democratization of the computer. It was the personal computer, it was the internet. It was basically allowing us now to augment our brain power with machine power, and that allows us to move up to the next level of productivity. And the third industrial revolution is just the combination of the two, the digital and the mechanical. And this is not new, right? Factories have been digital for decades. But in the same way that the digital revolution, I think, doesn't start with the invention of the computer, but rather the personal computer, I would argue that it's not the invention of digital manufacturing, but the democratization of digital manufacturing. And that's been only going on for the last 5 years or so. So basically, over the last 5 years, something which is described as, you can call it digital manufacturing or desktop manufacturing or the maker movement, which is basically the web generation meets the real world. Three big things have changed. See, there's that three.
Oh, yeah, here we go.
Yeah. Number one, desktop. That 3D printers. And quick show of hands. How many people here have seen a 3D printer? Yes.
OK, now how many of you own a 3D printer?
Not bad. There were a couple of hands out there.
I just lost a bet with my daughter, so I now owe her a 3D printer. So I need to ask you which one I should buy her. But anyway, we'll get to that in a
Trust me, that's a win-win. You both won on that one.
OK, good.
So by the time we're done, I want those of you, at least those of you with children in the audience, to consider getting a 3D printer this next holiday season for your home. In the same way your parents got a home computer, it's time. It'll change their life. My kids have grown up with a 3D printer. It's amazing. So there's the desktop. That is that 3D printers, which used to be industrial tools, are now cheap and easy and small, and you can have them on desktop. And that means that regular people can use them for whatever reason they want. The same way the personal computer liberated us to do dumb things with computers, which ultimately created innovative, awesome things with computers, we are now liberated to do the same thing with desktop fabrication. And that also includes other digital desktop things like laser cutters and CNC machines and 3D scanners, et cetera. The second is digital. The fact is that these designs are going from idea onto a screen and only then to the machine. And because they go onto a screen, they have those beautiful qualities of digital, which is that they can move. They can be shared. You can collaborate together online. And so they fit into the web's innovation model. Then they go on screen through something called CAD, computer-aided design. But CAD used to be super hard, $5,000 a seat, go to school, learn it, you need professional degrees. And now, like my children, do it on the web. It's gotten super easy in the same way desktop publishing became easy. OK, so that has created that sort of democratization moment, that bottoms up, this sort of explosion of participation. The third word is cloud, which is desktop fabrication is not mass production. You're going to make 1 or 2 or 3 things. But how are you going to make a million? And the answer is because that design started digital, it can go up to a factory. That same digital language that drives the machine on your desktop will drive the biggest factories in the world. And you can now click a button and get robots in China to work for you. And they take PayPal. So those 3 words, desktop, digital, cloud, have the necessary ingredients to achieve a kind of a web-like transformation of manufacturing, the way the web did for media and information industries.
Now, the thing is that a web page can have a variety of media on there. and the variety has only gone up, and the fidelity has only gone up. Whereas the analogy with 3D printers can print in a couple of colors of quite cheesy plastic. And then if you take that design, you can then send it off to somewhere else, and they can make it for you out of a couple of different metals. This is a very different thing from printing or creating entire objects. And a lot of people sort of say, oh, great, when can I print an iPhone? You're not ever going to be able to print an iPhone. So how do you, isn't there a bit of a disconnect here between the vision and the actual reality, which is that you and your children are printing out Darth Vader heads at home?
Yeah, exactly, we are.
So, so there's a bit of a gulf between that and sort of revolutionizing manufacturing. So what's the bridge between those, the reality and the vision?
So this is, what you're describing is sort of the intrinsic differences between bits and atoms. And atoms are definitely harder. Atoms have to obey the laws of physics. Well, I suppose there's also laws of physics.
Well, there are lots of different kinds of them, is the other thing.
And there's lots of different kinds.
Materials
are complicated. So to use that desktop publishing analogy, publish used to require a factory. That factory is called a printing plant, and you need typesetters and guilds and unions, all this kind of stuff. And then it became a button in your browser. And you at work can press a button and reach 1 million people. That's called publishing The Economist. And I at home can press a button and reach 8 billion people on the web. Well, I suppose we could both reach people on the web. But the point is that publish has turned into a button in the browser, and we have equal access to the market. That is not true for manufacture. I can create a button in the browser that says manufacture, but you're right, it's not going to manufacture an iPhone. I can manufacture maybe 1 material or 2 materials or something like that, but the complexities of actually getting atoms to fit together and work are much more difficult. So, although we've democratized entry into the market, when you're ultimately doing something complicated, you end up going into the traditional manufacturing industry.
And isn't that the hard bit? Because if you look at something like the glyph is beautiful, but it's a single, it's one of a small number of products where you can, this is, the iPhone tripod adapter. So the guys who invented it, they muck around with CAD, they print it out on plastic. Actually, they go off to Shapeways and have them ship them prototypes. They iterate on it really quickly, and then they can have a traditional production line make it through whatever it is, injection molding. But the thing is, this is basically a funny shaped thing that's made out of one material, and that's so tell me how that fits in with this.
This is a Pebble smartwatch. Anybody here heard of the Pebble smartwatch? Oh, interesting. Quick show of hands.
You can't just print one of those out, though. So how does the...
Well, bear with me. Anybody here heard of the Sony smartwatch? Nobody. So the Pebble smartwatch came out of the maker movement. This is 4 kids in Palo Alto. And on the same day that Sony launched their smartwatch, these 4 kids in Palo Alto launched this project on Kickstarter. Now, this wasn't 3D printed, but it was sort of prototyped with all the various tools we were talking about. Electronics, 3D printers, some software, that kind of stuff. And it wasn't funded by venture capitalists. As a matter of fact, it was rejected by venture capitalists. It was funded by the crowd on a crowdfunding site like Kickstarter. They raised $10 million, sold 80,000 pre-orders. And at that point, they took that prototype, and they then went into the traditional manufacturing. They flew to Shenzhen, and they, et cetera.
So the point is they could get to the starting line more easily.
Precisely.
Right. So what does that mean as far as the balance of power between...
And they kicked Sony's butt.
Yeah, well, absolutely.
Which is
So how does that affect the balance of power between startups and incumbents then? I mean, this is all new technology. Is it necessarily something that smaller, agile startups are going to make better use of than big, lumbering companies like Sony?
Not necessarily. I mean, I think absolutely, because there are more small, nimble startups and individuals. And I mean, here I am. 5 years ago, I was playing with Lego with my children, and now I run an aerospace company. I couldn't barely spell aerospace 5 years ago, but I didn't have to because stuff got easy. So what you're going to see is not so much that the small startups and individuals use the tools better, it's just there's more of them. And although they use the tools worse, sort of lots of people sort of fumbling around can actually innovate in a way that the professionals doing it right can't. Witness the web.
The internet versus telecoms, yeah.
Precisely.
Yeah, it's a very similar thing. So what does that mean as far as, one of the things that people seem very optimistic about, yes, this will lead to more innovation. I think that's, a plausible claim to make. A less plausible claim is that this will somehow give America in particular, seems to be keen on this idea, give the Western world a sort of ability to take manufacturing back, and that all of this outsourcing everything to China. I mean, you're actually talking about outsourcing to China being a part of this model, but does this idea that this is going to help repatriate manufacturing, is there any truth to that?
Well, I'm going to argue that it levels the playing field in a couple of respects. Matter of fact, I'm going to go further than that. I'm going to argue that what I'm talking about could ultimately reverse the arrow of globalization. So the first 500 years of globalization were driven by money, which is basically what we call labor arbitrage, the search for lower cost labor, and that typically took us east. Today, I mean, I run 2 factories. I work in Berkeley. I work here, just literally down on 7th Street. Come visit me sometime. I work in a manufacturing complex where they make furniture. How is it possible to make furniture in Berkeley, really complex metal furniture? And the answer is robots. It's all robots. And the designers are 10 meters away from the factory. The supply chain is 10 meters long. What we're seeing with this digital manufacturing revolution is that the labor component of making things is shrinking, even in China. And today, we all buy robots for the same price. So as labor becomes a smaller fraction, then other factors start to kick in, like time and flexibility. So we started with our manufacturing in China. We brought it all back to San Diego and Tijuana, Mexico, because what mattered to us was speed and nimbleness. We have a just-in-time, manufacturing process where we can make things, we can change the design in 24 hours. I think that if the first 500 years of globalization were driven by money, the second era is going to be driven by time. And that's what automation does. It levels the playing field on the monetary front and allows us to innovate faster by using these machines for what they're best at, which is being infinitely flexible.
Well, it does this for things that are relatively complex and produced in relatively small numbers. But for really, really mass production, then the chances are that other things will
China
dominate.
has nothing to fear.
Right.
When you're going to make, a 10 million, Happy Meal toys, it's hard to beat China on that. But there are these, so for mass production, I think the existing systems work pretty well. And for prototyping, making a few, we just talked about the maker movement's getting pretty good at that. Right. There's a really interesting space around 10,000.
And it's not the short head or the long tail, it's something in the middle.
It's the fat middle, right? So 10,000 is such an interesting number because 10,000 is too small for mass production and too large for an individual. And yet we've seen on the web what 10,000 can do. 10,000 fans, if you're a band, is the start of a career. 10,000 products, sold to a niche, discriminating consumers who will pay more across a global market is a business.
How many Pebble watches were they aiming for? It's a kind of number you aim for.
They aimed for 10,000. They ended up with, their sales over 100,000 at this point. They're going to go to millions.
But the point was that was their target. Yeah.
10,000 is like the perfect Kickstarter sweet spot. And what's great about 10,000 is that we now have the ability to make that. At 10,000, you're not dealing with sort of 1% margin differences. That doesn't decide. I mean, simply just being able to make it a kind of an affordable price, even if it's $10 more than it might be elsewhere, is good enough. Because that market, that niche market, is so discriminating. They know what they want. You don't have a lot of competition in this space, and they're not super price sensitive.
So over and over again, then we have this lower barriers to entry, more scope for people to try stuff that they used to be able to more cheaply, more easily.
And between the crowdfunding sites and the sort of democratization of manufacturing, those products that wanted to exist at 10,000 can now exist at 10,000. We can explore the space of what products can be, both in terms of better products, like this was not the first smartwatch, but it's better, and also products that never existed before. And some of those 10,000s will become the next 10 million.
Finally, you were telling me earlier on that you were misquoted as saying this was bigger than the web, but that you didn't mind. Why is this?
Well, so if this is the digital manufacturing revolution, then here's why it might be bigger than the web. We are talking about the web's innovation model brought to atoms, not just bits. Well, atoms are a bigger market than bits. The physical world, we are here in the physical world. Between agriculture and manufacturing and construction, it's making stuff is a bigger market. It's got heavier, more economic weight than making information. If this innovation model can transform making stuff the way it transformed making information, it could be bigger than the web.
Brilliant. Chris Anderson, thanks very much indeed.
Thank you.